Hi, I'm Alex, and I'll be teaching you to think object-oriented. Until now, you have probably been coding in so-called procedural style. Your code was a sequence of steps to be carried out. This is common when doing data analysis. You download the data, process it, and visualize it. Procedural thinking is natural. You get up, have breakfast, go to work. This sequential viewpoint works great if you're trying to plan your day. But if you are a city planner, you have to think about thousands of people with their own routines. Trying to map out a sequence of actions for each individual would quickly get unsustainable. Instead, you are likely to start thinking about patterns of behaviors. Same thing with code. The more data it uses, the more functionality it has, the harder it is to think about as just a sequence of steps. Instead, we view it as a collection of objects and patterns of their interactions, like users interacting with elements of an interface. This point of view becomes invaluable when designing frameworks, like application program interfaces or graphical user interfaces, or building tools like Pandas data frames. It will help you organize your code better, making it more reusable and maintainable. The fundamental concepts of OOP are objects and classes. An object is a data structure incorporating information about state and behavior. For example, an object representing a customer can have a certain phone number and email associated with them, and behaviors like place order or cancel order. An object representing a button on a website can have a label and can trigger an event when pressed. The distinctive feature of OOP is that state and behavior are bundled together. Instead of thinking of customer data separately from customer actions, we think of them as one unit representing a customer. This is called encapsulation, and it is one of the core tenets of object-oriented programming. The real strength of OOP comes from utilizing classes. Classes are like blueprints for objects. They describe the possible states and behaviors that every object of a certain type could have. For example, if you say, every customer will have a phone number and an email and will be able to place and cancel orders, you just defined a class. This way, you can talk about customers in a unified way. Then a specific customer object is just a realization of this class with particular state values. In Python, everything is in objects. Numbers, strings, data frames, even functions are objects. In particular, everything you deal with in Python has a class, a blueprint associated with it under the hood. The existence of these unified interfaces is why you can use, for example, any data frame in the same way. You can call type on any Python object to find out its class. For example, the class of a NumPy array is actually called ND-array for n-dimensional array. Classes incorporate information about state and behavior. State information in Python is contained in attributes, and behavior information in methods. Take a NumPy array. You've already been using some of its methods and attributes. For example, every NumPy array has an attribute shape that you can access by specifying the name of the array, then dot, then shape. It also has methods like max and reshape, which are also accessible via dot. Attributes, or states, in Python objects are represented by variables, like numbers or strings or tuples in the case of NumPy array shape. Methods, or behaviors, are represented by functions. Both are accessible from an object using the dot syntax. You can list all the attributes and methods that an object has by calling dir on it. For example, a NumPy array has methods like trace and transpose. Let's stop here for now. Don't worry if it seems confusing. It's a different way of thinking and it will take some time to get used to. Now head over to the exercises to review what you've learned.